I'm Connie Harrington. I'm a research forester with the Pacific Northwest Research Station in Olympia, Washington. And I'm going to talk about the Olympic Habitat Development Study. It's an early example of variable density thinning. So I'm going to first talk about the differences between variable density thinning and standard thinning, and then I'll jump into some of the specifics of the study. The Habitat Development Study was originally started by Andy Carey and myself. Many of you know Andy Carey was a wildlife biologist that worked for the station for many years. Leslie Brody works with me, and she's been quite involved in vegetation and tree measurements. And then several years ago, Scott Roberts came out from Mississippi State on sabbatical. And more recently, John Willis, who was a colleague of Scott's, has joined me to work on the project. So I'm just going to jump right in. As I say, we're going to start with talking about thinning and then get into the study itself. So as most of you know, thinning is the removal of some trees in a stand to allocate growing space to other plants. And traditionally, the biological intent is to benefit the remaining trees, but there isn't any reason why thinning can't be done to benefit other things, such as understory plants or other components of the stand. So, but thinning can be implemented in many ways. You can do it in a fairly uniform sense. In this case, it's uniform standpoint of thinning in a natural stand or an older stand, not a uniform plantation. And then down in this lower right-hand corner, see an example of variable density thinning, where you've got areas with no thinning, and then areas where everything's been removed, and then other parts of the thinning. So with uniform thinning, traditionally, most thinning has been applied in this fairly uniform way to give the remaining trees similar amounts of growing space. So you want to produce maximum utilization of growing space. The idea is that you're producing wood. And for non-uniform thinning, often called variable density thinning, you want to increase growth of trees in portions of the stand, but also allocate areas for wildlife habitat or biodiversity. So with variable density thinning, you have different components. These components are not the same in all thinning prescriptions, but often you have three different areas. You have no-cut areas, also called reserve areas or skips. And the purpose is to protect snags, understory plants, or other special features. And these no-cut areas are also usually no entry areas for equipment. Gaps, also called openings or holes. The purpose can be to benefit understory plants, but also to encourage tree growth and crown development on trees on the edges. Can be designed to favor tree species retained in the gaps, if that's part of your prescription. And then the matrix, the general thinning in the rest of the stand to increase tree growth. And what's done in this matrix can be done uniformly or varied to meet your objectives. So a lot of times people ask me, well, what percentage did you do for this? Or what percentage did you do for that? And really the components are not going to be the same in each unit or each stand. In some cases, you might have uniform thinning and just put in a few gaps. Another unit might have uniform thinning with a few skips, or other stands might have both skips and gaps, but different numbers. There's no cookbook or right answer. It depends on what you're starting with and what your objectives are. So most of us, many of you on the call are familiar with how you specify a uniform thinning. Usually talk about what percentage of the trees removed, or the spacing of the remaining trees, basal area of the remaining stand, or other measures such as thin to a certain relative density. And usually there's going to be some description of priority tree species to cut or to retain. But with variable thinning, you're going to have some additional types of specifications. If you're having gaps, you're going to specify the number and the size of the gaps, what percentage of the area is going to be impacted. Are you going to remove all trees in the gap or only some species? What's going to be the size and number of the skips? Are you going to allow equipment traffic? And then the thinning specifications of the matrix could be done in the same way as you would a uniform thinning, or they could be implemented in a more complex fashion, depending on what the stand conditions are and your objectives. And I don't know why we keep hearing those little noises, but hopefully they're not too objectionable. So I just always like to emphasize there's no right or wrong way to implement variable density thinning, but there should be reasons for the prescription. So where you want gaps or where you want skips, thinking about what the logging method's going to be, what the snags, what the actual stand composition is, what you're trying to achieve. So the Olympic Habitat Development Study was started with the congressional earmark in 1994 to establish old growth demonstration areas in Washington and Oregon. And after some discussion with various people, it was decided to start a new study in Washington. There was a study already underway in Oregon that is kind of a sister study to the Habitat Development Study. But the purpose of the study was to accelerate the development of stand structures and plant and animal communities associated with late successional forests. So one of the things that we always like to emphasize is that we're trying to accelerate the development of conditions, but things are not going to happen right away. So sometimes people are critical that they think that these things are going to happen right away, that we're going to be able, that we're either claiming that we're going to be able to develop the conditions of an old growth forest right away, or they're disappointed that things can't happen right away. But in fact, we have to be patient. So many young stands have simple stand structures, and these are examples of some of the stands in the Habitat Development Study. They were kind of 35 to 80 years old, conifer dominated, and basically had very simple stand structures. Very little, in most cases, of an understory or a midstory, and many of the stands had very little understory vegetation developed either. So talked about trying to develop late successional or old growth conditions or features. And so what are we talking about? With live trees, we want to develop larger trees, those that are greater than 32 inches in diameter. With Douglas fir, we're talking about, with that particular type of site, more than 8 per acre, greater than 32 inches in diameter. But also for tolerant associates, we want to develop trees like hemlock and cedar greater than 16 inches in diameter. Deep multi-layered canopies, conifer snags, and logs. And with conifer snags in particular, we're trying to develop those larger, have those larger snags and larger and longer logs. So with the Olympic Habitat Development Study, we established 8 sites on the Olympic National Forest. And we've got 3 on the east side of the peninsula, 3 up in the near Forks, and then there were 2 sites originally established over in the Quilcene area. This Eats site has never been thinned. So it was initially part of the study, but has never been thinned. So we don't have any data on how it's developed after thinning. So as I said, these are mostly kind of 40 to 70-year-old coniferous stands, primarily Douglas fir, western hemlock, Sitka spruce. Two of the blocks had been commercially thinned 10, 20, 30 years in the past. Some of the blocks were planted and some were naturally seeded. So the purpose of our treatments, we wanted to accelerate development of stand structures. And we thought this, by the thinning, the variable thinning, would create a variable light environment that would increase the variability in tree growth and stand structure and understory vegetation. The skips would preserve snags and species sensitive to disturbance. And then we also did some coarse woody debris enhancement to add cover, woody debris cover, and increase microsites. So some of the structures that we developed in skips, we had the large snags, but we also had large stumps and just areas of large down debris and logs. So as I say, we always like to emphasize the importance of specificity in a prescription, but just this is showing you what we did. So in this particular case, 10% of the area was in skips. So kind of from a quarter acre to 3/4 of an acre. We were trying to protect the largest snags, and we also wanted to keep the skips at least one chain from the gaps. The gaps, plus any existing openings in the stand, were to account for 15% of the area. They're about 1/10 of an acre, slightly larger if we were adding on to a previous opening. And in our case, we were not cutting any preference species. So we were not cutting any hardwoods, cedar, Pacific yew, Pacific silver fir, basically not cutting any of the non-dominant species in the gaps. And then in the matrix, we did a light thinning from below. Now we said that the basic thinning was done on 75% of the area. And sometimes people say, well, couldn't you have increased the number of gaps or number of skips? And yes, it certainly is possible. But it also becomes complex if you're trying to keep the gaps away from the skips. So if you're thinking about doing a particular treatment, you would need to try and move things around and see what would be, what's feasible. In this particular case, the black circles are large diameter and tall snags, old growth snags. We were trying to preserve as many of those as possible. Whereas the squares and the little triangles are smaller snags or hardwood snags. And you could see here, for example, over on the side, we had an existing opening, and then we expanded it a little bit by putting in a gap next to that opening. So just an FVS view, SVS view of what the stand looked like to start with, one of the stands. And we exaggerated the height of the snags in this figure just so you can see them better. But you can see over here, we were trying to, this is one of the skips, and we were protecting some of the snags in that area. So I'm gonna, for the results that we have from the study, we have implementation issues, and I've published on that before, but basically we had very few problems in implementing the treatments. The greatest difficulty was trying to decide how to mark things back in the mid-90s when people hadn't done many of these kinds of prescriptions before. And also when the Forest Service had more restrictions on what they could do. So it was a question of whether every tree to be cut had to be marked or whether things could be done. This designation by description, different types of ways of setting up timber sales. Stand damage in terms of implementing these prescriptions was minimal. There was a little bit of logging damage and there was some windthrow, but very little windthrow. And I think the Windthrow is minimal in part because the size of the gaps was small. So I'm going to talk a little more specifically about tree growth and understory development. So here's an example, a slide from effective thinning and diameter growth through 11 years post-treatment. And this is on based on 5 stands. So we're looking at growth, that 14-year growth in 5 stands, the portion of the stand that was thinned and the portion that was skipped. And you can see that it was greater in the thinned portion than in the skipped portion. And I'm sure some of you are saying, well, yeah, I mean, that's why you do thinning, to increase growth. But some people had said that it wasn't likely that we would see an increase in tree growth in some of these older stands. Some of the stands were 50, 60, 70 years old. So we were able to document that there was an increase in growth in the thinned areas. So I'm going to show a couple slides of diameter distributions from 2 of the stands, just to give you some examples. So this first one is Fresca. It's one of the stands. It was around 70 years old up near Rail. And this is the pre-thinning diameter distribution. And then 14 years after thinning. And you can see that there's a big increase in the number of stems in the very smallest diameter class. And also that the diameter distribution, aside from this increase at the smallest classes, has been shifted to the right, which is what you would expect with time. And just another way of looking at it, this pre-treatment diameter distribution is this blue kind of cyan line. And then right after thinning is this green line. And then the red is 14 years later. So you can see that the thinning didn't remove any trees or very few trees in the larger diameters, and then did kind of a light thinning through the middle and smaller diameters. And then in the very smallest diameters, these wouldn't have been removed by the thinning per se, but damaged from forest operations. So we can look at different parts of the stand. So in this case, we're looking at the unthinned area, the skip, initially, and then 14 years later. And so the difference here, since there wasn't a lot of growth in the skip, a lot of this difference is actually mortality. But in some of the larger trees in the skip, there was some growth. Now I have these some yellow boxes here, and this is just reminding you of some of the important sizes in terms of the old growth definitions. So if we wanted things that were greater than 50 centimeters or kind of 18, 20 inches, or if we wanted things that were larger, what's happening in the skip. And then over here we have the thin matrix, and you could see the, oops, let's go back one. Here we have the thin matrix, and you can see that this matrix has, the diameter distribution is clearly shifted to the right after the 14 years. And there's an increase, particularly in the trees, the number of trees that are greater than this, this diameter that we're trying to reach, this 80 centimeter diameter. So rail is another stand. Just give you one other example here. And rail is a stand that had been thinned in the 80s, lightly thinned as part of a salvage from some bark beetle kill. And so because it had previously been thinned, there were quite a few trees in this very smallest, this is kind of less than 2-inch diameter distribution. And 14 years later, you can see we still have a lot in that size class, but we also have a large number in the next diameter size class up. So similar graphs to what we saw before. Here we have the mortality in the skips. And then here we have this increase in the diameter distribution, the shift in the diameter distribution, in particular in the thin matrix. Now we're trying to get trees greater than 80 centimeters, and you can see we haven't quite made it to that in 14 years in this stand. So Carson James was a master's student at Mississippi State who came out here one summer, collected some additional data. And one question people often ask is, well, what can we do with the understory hemlock? A lot of times you get a lot of understory hemlock. And the Ranger District had tried doing some pre-commercial thinning. And so Carson went in adjacent to one of our stands. We had a stand called Rail, and the district went in. They had another area called Rail Sighting. And they did some understory thinning at 2 different stands. So in this stand, they went in and did in both stands, they did a commercial thinning in 98, kind of 98, 99. And then in this lower stand, they went in and thinned the understory. And then in this stand, they thinned the understory then. And so what you could see is that in terms of the understory hemlock diameter growth, what was really important was thinning the overstory rather than thinning the understory in terms of increasing the growth of those smaller trees. So, but thinning the growth of the smaller trees, I think, was effective in terms of opening up the area to make growing space available for shrubs and herbaceous species. So mid-story western hemlock, Emily Comfort, who was another student from Mississippi State, came out and worked with us. And we could see that this variable density thinning increased the growth of mid-story trees. And we could see an increase even the first few years after thinning, and a larger increase after that. Of course, we're not just looking at diameter growth. We're trying to look at a lot of different stand characteristics. And this one is crown length. And if we look to see 14-year change in crown length, in the skip, the crown length is actually declining because branches are dying, whereas in the thinned matrix, you're maintaining the existing crown, and then crown also is increasing as the trees continue to grow in height. And then this is looking at the trees that are the largest in the stand, and you can see a fairly large difference between the change in crown length. And as you might expect, the crown length increased the most for the species that were shade tolerant, so the western hemlock and the Sitka spruce, whereas the Douglas fir, which is less shade tolerant, tended to have a decline in crown length. And I mentioned before that one of the reasons for gaps is to increase the growth rates and the crown of trees near the gaps. And so this is the change in crown length for trees that were within 10 meters or half a chain of the gap. And then this is the change in crown length for those that were further away. So the gaps were really quite effective in increasing both growth rates and increasing crowns, crown length, branch retention of trees near the gaps. So I know a lot of times people say, well, the gaps are too small to regenerate the stand, but that was not our intent. The intent was not that this was a regeneration cut, but this was a thinning in which we were trying to improve different aspects of stand structure. So just some more details, and you can look at these later in terms of what's going on. You can see, I guess, in the skip again, where crown length is declining, but it's definitely increasing in the thinned areas. And we're getting the greatest increase in crown length in hemlock, and very little in spruce. But we also can look at live crown ratio, crown width. We're actually increasing crown width, especially in spruce. So there's just many ways that we can actually document the effects of these treatments. And this was published in a paper that John and Cheryl of us published last year. So talk about seedlings and saplings. And it often gets complicated because the stands started differently. They had different numbers of seedlings and saplings to start with. So I'm just going to give you a couple examples. This over here, I have a graph where we're talking about seedling density. And in the gaps, in the red, you can see it went up and then went way down. And sometimes people get discouraged when they see something like this if they are trying to increase the number, the regeneration. But if we follow the red line over here, where we're talking about saplings, we can see that we've had a big increase in the number of saplings. So we had a decrease in the number of seedlings over time in the gaps, but an increase in the number of saplings. So the trees were moving from the seedling class into the sapling class. And in this case, we're just calling saplings anything that's has breast height. So anything that's large enough to measure a diameter becomes a sapling, as opposed to something that's shorter than that. So here's Fresca. Fresca was one that didn't have a lot of seedlings to begin with, very depauperate understory. And we actually increased the number of seedlings, but we also saw a big increase in the number of saplings in the gaps. So variable density thinning increased the seedlings in the gaps in the thinned areas and increased the saplings in the gaps. So this is just a third stand, just to see how different they are. We can see in this case, variable density thinning really reduced the number of seedlings. You can see here the gaps actually have the fewest number of seedlings, and that's because of the equipment traffic. So as the gap areas were actually equipment, logging equipment went through the gaps, it reduced the number of seedlings at the beginning. But over time, you can see that we've increased the number of saplings into that, in that size. And just one last one. This one already had quite a few seedlings. And so what it's really doing is moving the saplings into the next size class. So in this case, there were already quite a few, and it looks like it's really gone down over time, but that's because they've just moved into the next size class. So just, this is looking at those old growth characteristics for Fresca and rail, just two different stands. Fresca is one that had not been thin previously. Rail's one that had been thin previously, but they had different species composition, but about the same age up near forks. So we can see what our targets were. So live trees per acre greater than a certain size. The target is 20 per hectare, and Fresca has 19. So in terms of big trees, it's basically meets the target. Tolerant trees, so the mid-story hemlock and spruce, we've got many more than the target. The snags were close to the target, not quite there, but close. And then the deep multi-layered canopy, that's something that's not very well defined. I don't think we're quite to that stage yet. We have different height classes, but we don't have as deep and multi-layered as I think would be desired. Another stand, this rail stand, the target's 20 for these largest trees, and we don't have any. But there are quite a few greater than 60 centimeters as opposed to the target of 80. So over time, I think we'll get there. But we certainly didn't get there in the 14 years, which is when what these measurements were based on. We have many tolerant trees, fair number of snags, but we're definitely not there yet with the larger trees. So just briefly, one other thing that we did as part of this study is we established some additions of coarse woody debris by making log pyramids or log piles. And you can see over here in the left-hand side, a couple years after treatment. We actually waited to create these structures until 2 or 3 years after treatment, so we could take advantage of any windthrow that came down after the treatments. And then you can see what some of these look like several years later. So these are not having small diameter or smaller diameters logs are not going to act in the same way as large old growth logs would. But on the other hand, they're clearly providing some of the same features in terms of nurse logs and also habitat elements for salamanders and small mammals in terms of hiding cover and feeding cover. We had a technician who worked for us for a few years who was quite a fun artist to work with, and he made several sketches for us that we've posted on our website. And this is one of my favorite ones, but we had a lot of discussion about what we should call those log structures, and some people wanted to call them pyramids. So it was kind of a joke about our log pyramids. So a little bit of information about understory development. As you would expect, openings in the canopy, whether it's thinning or gaps, can affect the development of herbaceous species, shrubs, tree seedlings. And there's a lot of different ways of looking at it, and I'll just give you a couple brief ideas. Once again, like with the seedlings and saplings, depending on what you start with, the stands can develop in very different ways. So in this case, that fresca stand that had not been previously thinned, we're looking at this percent cover. So this is the percentage of plots by different cover categories. And you might think, well, why did all of a sudden there was a big increase in the cover in some of these higher categories in the control? And that's because there was an ice storm, which opened up the canopy. There were a lot of broken branches, and so there was some kind of short-term increase in cover. But over time, then it started going back again, and we're not too different from really what we started with. Whereas in the variable density thinning, we created a wider range of overstory conditions, and that clearly resulted in a very wide range of understory conditions. So we created, we still have some that are this very low cover, just like in the control plot, and these would be areas that came from the skips, but then we have the thinned areas and the gaps. So just as an example, looking at 4 of the stands, this is herbaceous species. So we've got these, the first bar in each group is from a control plot, which is adjacent to the variable density thinned plot. And we can look at the cover, total cover, on the whole plot at the beginning, and then year 3, 7, 10, and 16. So you can see that there's an increase in the cover of herbaceous species at all time periods, but in some cases it's fairly small. But over time, it can be increase and then decline again, depending on what's happening with the overstory. So this is percent cover of shrub species, and there's a big difference in what they started at. So for example, some of them started at relatively low levels and they stayed low in the control plots, but in the thin plots they increased quite a bit. Snow White is an area that had been thinned in the 70s, so there was not much difference between the thinned plot and the control plot at the beginning, and there was very little difference over time. Looking at specific species, here we have a bracken fern. We've got a big increase by year 7. These two lower lines are the control plot and part of the skip in the variable density thinned plot. And then this is a gap, and then the thinned area. So in the gap and the thinned area, they increased by year 7, then declined by year 17. But it did depend on which species you were looking at. And for red huckleberry and for several of the shrubs, there was very little increase over time. And you may say, well, I would expect the thinning to have done more. But many of these species were heavily thinned, heavily browsed. And so we can't really see a difference in the cover of those species. This is another one of the installations. This is Bait over near Quinault. And we initially got a big increase. You can see this, it was like 65, 70% cover by year 7, this non-native evergreen blackberry. But over time, it went down basically to 0. On the other hand, on those same plots, we got a big increase in salmonberry. So you can, it wasn't fun going through the plots when it had evergreen blackberry, but it wasn't necessarily fun going through the plots when there was a lot of salmonberry. But some species, like the salal, had very little change. Other species, like these rubus species, there were large differences. So we looked at a lot of different parts of the stands. We talked about the understory trees, herbaceous shrubs, and on this particular stand, we can see that the shrubs, we didn't increase too much. They went up just a little bit and then down, but the big improvement is really if they were close to a gap. But the effect was small, but if you looked at understory trees, you could see a much bigger effect. So it depended on what you started with and then where you were spatially. Are you close to a gap or are you further away from the gap? Did you start with a stand that had a lot of understory or with a stand that didn't have much? Were you in an area where there was a lot of browsing or not much? So it's easy to, it's common for people to want to assume that we understand it all or we can summarize the results easily, but in fact it's quite variable. And here again, we have some of these browsed shrubs in a gap. So we increase the development of those plants, but our numbers don't really show it. So here is just a different stand, and you can see that the numbers just jump around. Some cases, this is a shrub, it goes up. Other cases, something, well, this gap in this matrix, thin matrix, there was very little. The understory trees went up and down, but other things stayed very level over time. So people often ask about non-native species, and initially we had a fair number of non-native species, particularly up in the gaps. This is the gaps, in the thinned area, and this in the control and the skips. But the number of non-native species has really declined over time. So we're down to 4 species. We have a digitalis, ilex, which is a holly, that non-native blackberry, and wall lettuce. So we did get quite a few native species in parts of the stand, but they've also been declining quite a bit, substantially over time. So understory development, the initial conditions really influenced the early results. Results differed across sites, but overall, the thinning and gap creation increased the cover of shrub species, temporarily increased non-native species, and increased tree regeneration. So, in conclusion, I didn't present any information today, but the treatments were definitely operationally feasible. These are all done as advertised timber sales, and we were able to achieve the implementation of our treatments, and they were, I think, we were quite successful in achieving what we wanted to do. Windthrow may occur if the stand has a high height diameter ratio and the gaps are located on ridge tops. We had this on just a few of our plots. It was not a major problem. But we can conclude that the older stands do respond to thinning. Variable density thinning did increase tree variability in growth rates and in structural characteristics, crown length, and in the development of mid-story trees. And the plant communities are becoming more variable in some of the variably density thin stands. So the habitat development study has been used for many purposes, including providing data to fit and test growth models. So for example, the forest vegetation simulator. Peter Gould took the lead in this several years ago, in which we pulled together data from a lot of different sites, in which we had these sites up on the Olympic Peninsula, as well as other research sites and other types of studies. But generally, we were, in this particular case, we were looking primarily at research studies, but then we also had this data in the background from FIA plots. So the old FES, these little black bars, are what FES used to predict for the diameter growth of small trees. And the actual growth rates are these tall green bars. And then after it was refit and updated in 2013, this is what it was predicting. So predicted versus actual for one stand. But you can see that the old version of FES just did a terrible job in predicting the growth of the small trees, those less than 4 inches. It just did not have the basic data initially to be able to do a good job. And so in the old FES, those trees never grew into the larger size category. And FES has always done a fairly good job in predicting growth of the larger trees, but it just wasn't doing a good job in predicting the growth of smaller trees. So it's really nice that we could use data from this and other research studies to update FES. So for those of you who want to know more, we do have a website for the habitat development study. We have what we call a virtual trail where you can go around to different portions, and a lot of the graphs that I showed you today will actually be on the website. We also have publications on the website and links to different types of things. So for example, if you go up to info, click on things, then publications is one of the categories. So just as an example, the virtual trail, we actually have 5 different virtual trails, one that emphasizes management, one that's looking at tree growth, one understory, one natural history, and one laugh and learn. And the laugh and learn includes all of the little cartoons that I showed in case you would like to use them yourself. The laugh and learn trail is always the most popular for people to look at. And we have some description of what we think are the take-home messages that go along with each of these cartoons. So let me see if I can make this work. We put out some time-lapse cameras at one of the sites, and you can see on the left is a skip, and on the right is a gap. And it's just kind of interesting to watch the light move through those. Oops, let's see if I can make it work again. Try this. So anyway, you can see quite a difference in the light patterns in the gap versus those in the skip over a several day period. So what's next? We would like to do some more detailed additional analysis of the understory and regeneration. John Willis, colleague from Mississippi State, is actually working on some analysis of regeneration, a more detailed analysis than we've done in the past. We'd like to look at snag falling rates. I know there's some models that predict snag falling rates, but generally they've come from data from fires, from wildfires, not after thinning. We'd like to remeasure all of these plots in the next year or two. That would give us 5 stands data up through age 20 and the 2 others up through age 15. Also hope that we can fund a postdoc or work with the university to accomplish additional analyses and publications. I think that habitat development study is definitely one of the oldest examples of variable density thinning. So being able to get this work into the literature, I think, would be useful for people who want examples that they can share with others and get a better idea of what the results would be. So I'll stop it there and see how we might handle questions. Ralph, are you there?
Yep, I'm here. So 2 ways you can ask questions. You can raise your hand in the panel and I can activate your mic, or you can type a question into the question panel and I'll read them. Kevin Alexander has a question. Is there any information on other harvest requirements or impacts such as mechanical damage or snag creation?
So we did publish we have published information on the percent damage and the Windthrow in I think it was 5 of the stands. And That information is available on the website, or if you send me an email, I can send you a link to that particular paper. What was the second part of the question? Is there a...
The second part of the question had to do with snag creation.
Yeah, so we didn't do any creation of snags. We were just looking at natural mortality and the longevity of the snags. And that's something we haven't analyzed, but this particular study didn't include snag creation. I would also say that people are welcome to email me for follow-up questions. I think I forgot to put my email in here, but it's just C Harrington, so CHARRINGTON at fs for forest service.fed.us.